Hello, lovely people of Kyiv. It's a pleasure to be here. So it's my first time in Kyiv. Well, actually, it's my first time in Ukraine. So, well, just want to say thank you for the warm welcome. It's been very interesting so far, and I hope to see more of the city, well, maybe later today and also a bit in the morning tomorrow. But yeah, hi, I'm Sebastian, by the way. People on the internet usually know me as ASCII-Disco, not to be confused with the house DJ that is written with a K, ASCII-Disco. So if you look me up on Spotify, that's not me. But if you look me up on Twitter and GitHub and basically everywhere with ASCII-Disco, that's me, not the DJ. I do work for Deutsche Telekom, and I do have a very weird job title. I don't know how they come up with that one. It still puzzles me after 5 years or such. I usually do work with JavaScript and HTML, CSS, Node stuff, but also a bit with Python and also Rust in the, well, past month, because I do a lot of embedded IoT stuff as I'm working in the field of smart home for over 7 years now, which is like building smart home products for end consumers. Yeah, so if you have any questions that you don't want to ask after the presentation in public, you can find me out there, come up to me, or you can send me them via Twitter, or you can write me a mail. My mail address is on my homepage, ascidisco.com. So yeah, I've been tinkering with hardware since 2011, roundabout. Mostly in JavaScript and therefore with Node.js. And aside from my day job, like working on consumer products, I try to reverse engineer and wire everything up that I can, well, get my hands on so that I can control it from a computer somehow. So mostly I'll be using an Arduino or a Raspberry Pi for that. But the thing is, you should know, I have absolutely no background in electrical engineering. And the good thing is, I don't have to, because nearly everything nowadays can be connected via USB. Well, maybe adapters to wireless networks like Bluetooth and Zigbee, or, well, mobile phones or tablets, funny gadgets like USB rocket launchers and stuff, they all can be connected via USB. And so therefore, as we want to talk about JavaScript and hardware today, we're going to talk about USB, well, the most universal hardware interface we can get our hands on. Before we'll get our hands dirty with some hardware demos and code, let's talk a bit about USB basics. And let's start with the history. I always do like to start with the history of things. This is also my main approach when I come across some new piece of open source on GitHub that I wanted to use. I always go back in the history, in the Git history, right to the beginning, because I think in the beginning, things are a bit easier to grasp, so no bloated code base. And I think it's the same with things like hardware standards. So USB started in 1994, or the development of USB. A group of companies that were very prominent computer companies in the 90s wanted to end the adapter madness, or the, well, protocol and port madness that we have. So, I mean, if you remember the days, so back in the 90s, we used basically PS2 ports for mice and keyboards. We used SCSI for external storage and scanners. We used parallel ports for connecting printers, and serial ports for basically everything else. And to bring all of this madness to an end, a team of engineers led by Intel, and there were engineers there from IBM, from Compaq, etc. They grouped together and started developing, well, USB, one bus system to rule them all. In late '95 then, the first USB hardware became available. And when I talk about hardware, it was only host systems, so nearly zero peripherals that you can connect to were available. And that kind of stayed the same until '98, when once again Apple decided to be the brave ones and to remove every other port and only stick with USB with the iMac G3 that was coming up then. So the iMac G3 only had USB connectivity. It was also, there was also no floppy disk in there anymore, so you had to buy one extra and connect it via USB. And that kind of like kick-started the whole USB thing, really, because all the Mac users then needed to buy USB hardware, and so more producers got into producing actual USB hardware. In 2000 then, there was a new spec, USB 2.0, so that one was faster, blah, blah, blah. But also in 2000, there was a very interesting development, because in the year 2000, we had the first USB mass storage device, so the first USB stick that you could shovel some data on. And when I say mass storage, we're talking about whopping 8 megabytes there. And it was costing around, if you translate it to euros or dollars, it was around 150 to 200 euros or dollars back then. The interesting thing though, I mean, many years, so these USB sticks, those storage devices, they became cheaper and cheaper. And I think for many years, people who were not that tech savvy associated USB with transporting data on a physical piece of hardware from one computer to another, like bringing music and photos to your friend's house. That was done with such an USB stick. Then in 2008, there was another development, the USB 3.0 spec, that was also called super speed because it was meant to be super speedy, was around. And yeah, that was basically a very short history of USB itself. And as you see, like, USB is quite an old technology. It was developed in, well, the mid-90s. So when we're going to talk about APIs and how we control those devices, it may look a bit alien. So those are not very webby APIs. That is one thing you should have in mind when we get down to code examples later on. But they're not so hard to grasp. Also, you might probably think that the electrical engineering behind such a sophisticated technology like USB must be extremely complicated, but to be honest, it isn't. So, as you see in this picture with the USB 2.1 Type B male plug, whatever, we have a gazillion different plugs in the world of USB. But that one is where you can see the best, I think, that we only have 4 pins and therefore 4 wires in the USB cable. Well, let's switch to some schematics. You see, we have 2 different pins that are only there for delivering power, the V-bus, which is actually capable of delivering power up to 5 volts to a device, which was also new when USB was introduced. No other bus system could do that before. You always had to connect external power supply. And if you have, well, power, you also need a ground pin. So those are like 2 of the 4. Then you have D- and D+, which are there to, well, transport data. And silly me in the beginning, with no idea about how USB works, I thought, well, that makes sense. Probably D- is for outgoing data or incoming data, and D+, well, for the other way around, which isn't true. So both data pins, both wires, transport bidirectional, so data in both directions, and they transport the same data at the same time. So this is some kind of hardware built-in security and fallback mechanism. So theoretically, if one of the cables breaks, then it should continue to work. Mostly it doesn't, but that's a different story. But per design, it could. So USB was introduced as plug and play. You probably all remember this, well, very memorable Microsoft keynote with the blue screen when Bill Gates plugged in some USB stuff. So USB was introduced as plug and play, but it often doesn't live up to that claim. So after you bought a device, let's say a printer, because that happened to me last year, it looks like this. So you look up the internet for a driver, install some kind of native application with very weird stock footage of children holding hands, because it's a printer driver, and that's what people want to see when they install it. then it doesn't work, and you think, well, maybe I've downloaded the wrong driver for my operating system. Is that supported? Then you think, well, no, I've just recently did this Mac update, and there's no driver, I don't know. But then you look up, and then you find in some other weird place on the internet another application. You install it, and maybe some scary operating system pops up and tell you, yeah, I hope you know what you're doing. You can break your whole system if you install this driver. And sometimes, well, that just happens. So a malfunction kills your existing setup, and then you're not able to print on any printer anywhere ever again. And then you try to remove the code, and it's very hard because it's buried down deep in some operating system layers, folders, and folds, and it basically sticks around forever. So it's not really what I would call plug and play. So how could a nicer way to interact with USB devices look like? Maybe like this. So you buy a device, you plug it in. Then a notification appears on your desktop, because that's what we're all used to, right? We all have smartphones, we're used to notifications. And the same thing could happen on your desktop. Click on it, it opens a website, and then it just works from within that website. So if you want to print something, you just drag a file onto that website, and it prints it. Fun. Well, I'm not the only one who thinks that this would be a very good solution for a proper plug and play. The Chrome team thought as well, and some people who started drafting the spec of WebUSB. This is basically a web standard embedded in your browser that, well, can talk to any USB device, nearly any USB device, natively, from just within your web browser. Nothing else needed. A few facts about WebUSB. So, like all the new and shiny web tech that we get, it's only available for security reasons via HTTPS or on your local host. So you can only use it if you serve your domain with a proper valid certificate, as you should always do. There is no native code needed. So if you have a device, there's no need to install some third-party software, additional drivers, etc. It's all abstracted within your browser. And it's, as we're going to see, it's like real plug and play. Enough university-style lectures. Probably you're already fed up with this. So let's have a look at some code. How do I do this? How can I connect a USB device from within our browser just using JavaScript? So first, we need to connect to the device, which means connecting to its device descriptor. Typically, there's only one device descriptor per device, and that provides some product information, and, well, it allows us to evaluate how many subsequent descriptors we need. We'll talk about that in a minute. So we can use the filter calls, and later on, we'll see why that is important to narrow down which device we're trying to connect to. So you can use different things like vendor ID or product name in that filter to narrow down the list of devices that your code can actually connect to. And once we're done with that, we can call device open, which is an asynchronous method, and that returns a promise to establish the first connection to the device. Once that has been done, we need to connect to the so-called configuration descriptors of the device. So theoretically, a device can have many configuration descriptors, but usually it only has one. And this is due to the fact that the first standard USB driver implementation for Windows couldn't handle more than one config descriptor. And many device manufacturers, especially if we're talking about devices that are basically around like for 20 years or so, many device manufacturers just stayed with this and only had implemented one configuration descriptor in their device. Configuration descriptors are there to measure the amount of power that a device needs, and they also are there for determine further subsequent descriptors, which I'm going to again about in a minute. And if that all seems very cryptic to you, let me give you an example from the web world for what configuration descriptors can be used for. So you probably, if you're familiar with REST APIs, you're familiar with versioning REST APIs. So you often see like routes with v1 / the actual endpoint, v2 / the actual endpoint. Something like this can be realized for USB devices using configuration descriptors. So let's say you download a new firmware actually for your device, and that changes the API completely. So manufacturers could then introduce a second configuration descriptor, second endpoint, that has the new API while maintaining compatibility with the old API using the old configuration descriptor. It isn't used like that much in the wild, but I think that gives a rough idea what configuration descriptors are used for in this ecosystem. So if we use the select configuration method that is present on a device object, we can select the matching configuration descriptor for our needs. So next, we need to select and claim an interface. And again, a configuration descriptor can have many of them. Interface descriptors, well, the technical description I copied is, interface descriptors will guide the endpoint descriptors in carrying out a specific device command with multiple interfaces working at once. Yeah, that is very spec-like. Let's put it that way. So you probably are familiar with devices, like multi-purpose devices that are a printer, a scanner, all combined in one single device. With different interfaces, they are able to represent different functionality behind their different interfaces. So, for example, if you have this multi-purpose device, you can have behind interface 0 the printing functionality, interface 1 is basically the gate to the scanning functionality, and so on and so on. It's just another way to, well, have kind of like a partition or separation of functionalities. So when we call claim interface, we are nearly done with connecting to a lovely device. Well, just nearly, I say, because after we claim the interface, we are kind of like ready to talk to the device in the end by using its endpoint descriptors. And again, well, an interface can have many endpoint descriptors, I think up to 127. So these endpoint descriptors are there to identify things like transfer directions. So some of them are just used for incoming data, some of them are just used for outgoing data. And yeah, so you can use them to send data to the device or read data from it. Well, we're not quite at the end, because if we're talking about sending and receiving data from devices, we're talking about 3 different ways of doing this. So most commonly used are probably the interrupt transfers. So all of this, by the way, all of these methods that come in pairs, so always 2 of them, one for sending data, one for receiving data. And interrupt transfers, as written, are usually used for like non-periodic and small, often device-initiated communication attempts that also often require a special latency. The method signature itself is, well, I think quite easy to grasp. So if you're transferring data out and if you're transferring data in, you need to tell this descriptor which endpoint you're going to talk to. So in this case, we're talking to endpoint 1. Then for outgoing data, you need, of course, the data you want to send to the device. This example is not 100% accurate, because usually you would send binary data, which means typed arrays, so in JavaScript land. So this is just there to keep the code short. And if you want to read from the device, you have to specify the length of bytes you want to read from the device at this point in time. So in this example, it would be 8 bytes that we will read from the device. Then we have control transfers, which are nice for small configuration commands. So if we're if we don't want to transfer big chunks of data to the device or read from the device, we usually use control transfers. They get bus priority, which can be important, and they have a very well-defined structure. So control transfers should be used for things like, if you have a robot arm, you can use different control transfers to say, okay, arm move left, arm move right, etc., etc. So they're very, very good for these small commands that just do a tiny thing and doesn't require lots of data. Don't worry about those bits yet. We'll tackle those later when we have a real-world example, because that can be a bit overwhelming. But with a real-world example at hand, it's actually, I also think, not too bad to grasp. Last ones that we kind of like shortly talk about are so-called isochronous transfers. I've never seen them in the wild with WebUSB. They're rarely used, and mostly they're used for audio and video devices because they are the only methods that are able to send a persistent stream of data to a client. So also, it's not transport safe, so bits can be lost, so unlike the other two methods. Basically, it's the UDP of the USB bus if the other two methods are the TCP of USB. I think that's quite something you can compare it to quite well. We won't use them in our examples. I really have to admit, with all my tinkering with devices, I've never seen them in the wild, and yeah. But maybe you're now eager to see some of that stuff in action, so let's start praying to the demo gods because, well, behold my stuff. I brought something. I was actually preparing 4 different demos, but I have to admit one won't work because my lovely receipt printer just, well, broke on the flight. Basically, its USB connectivity port broke. I tried to fix it with a paperclip and some tinfoil in the hotel this morning, but yeah, as said in the beginning, I have no background in electrical engineering, and I only electrocuted myself once, and I'll just like to keep it that way. So yeah, unfortunately, in the end, we'll only have like 3 proper live demos. And as it is always with hardware on stage, and I know this from various attempts, some of them work, some of them won't. So that was like honest with pray to the demo gods. But first we'll start with the tinkerer's darling device, the Arduino. And I set myself the task to, well, steer the Arduino from a browser. And I've been working with the Arduino and node-based applications for years now. And I mostly use it together with a node package that's called Johnny 5. Johnny 5 is a wonderful library that abstracts everything for you, wraps everything in a nice API, and also often has very good schematics that help you to wire up your things if you have, well, no idea what you're doing, actually. So as this is already JavaScript code, but only working in Node, I thought, well, wouldn't there be like a way to make this work in the browser as well? So let's see if we can actually, wait, I just have to mirror my display. 1 second. Okay, see something? Great. So I brought an Arduino here with a very simple example of an LED. Now I'm going to plug it into my USB port. One thing you should notice is the notification that appeared in the upper right of my screen. So the Arduino, so the sketch I applied to the Arduino is WebUSB compatible. And because the device announced itself as WebUSB compatible, my operating system, well, more or less my browser, recognizes that this is a WebUSB device. So all I need to use it, I would just need to press on that notification, and then it would guide me to a website where I can use it on. As I have already opened the website, I'm not using this. I just dismiss it. So yeah, I already connected to the Arduino, and yeah, I felt like, what would be the best way to demo this? Well, probably a bit of live coding in a browser. So I just use the standard Johnny 5 methods, and I think it's connected. Yes, it's connected to pin 13. So this is how you connect or how you start to steer an LED with Johnny 5. And then you should be able to, well, just steer it from a browser. Well, it's a bit light in here, so I can turn it off. I can turn it on again. And I can basically do everything that Johnny 5 allows me to do with this kind of hardware. So let's say blink, which takes a bit longer to transfer the command, and then it starts blinking. So there is no node server in between, no nothing involved. This is right from the browser. The browser connected to this device, and everything goes straight from the browser to the Arduino. So quickly switch back to the presentation. Well, thanks to Browserify, another tool that has been around for ages, it was as simple as swapping out the few modules that are Node.js only that often have a native C dependency, when replace them basically with the browser counterparts. One thing I had to do on my own then was write a serial port abstraction for the browser based on WebUSB. So it basically enables to use the plain old serial port protocol over WebUSB. One interesting thing though, if you ever developed for Arduino, you probably are familiar with a while true loop or some kind of read or write loop that you need to do. Because as USB, back in the 90s, of course, wasn't designed with the web in mind, it doesn't have something like an event handler mechanism. Even the APIs that we have in the browser there nowadays, those are very closely aligned with the USB spec itself. So we don't have any event handlers, etc. for them. So we kind of like need to build our own, and we usually do that with some kind of read loop. Might be while true or recursion, as in this example. Because if we would use the transfer in method from the device, we would only get data for that particular moment in time. So in this case, we only read 64 bytes, and we would only read them once. So we need to call this all the time to fetch and fetch data. So typical data polling. And yeah, usually, I mean, this is not code I would ship in production, but usually would do this with something like a read loop. Well, also I think now is a good time to talk about the things we left out about the control transfer methods. Because when we talk to the serial port, we need to do a couple of things that are realized with control commands. And one thing is to basically open up the serial port, say, hey serial port, we're here, we want to use you, we want to talk with you, through you. And those different properties we need to assign to this control transfer methods can be basically answered with a few W questions. So the request type, for example, is the which thing. So which type of command are we sending? USB has, the spec has a couple of standard device types. One of them is class. So if we say, hey, request type is class, and it is a device that adheres to a standard, like a printer, or other devices that are standardized in the USB spec, then basically the driver that sits in the browser, the abstraction layer, knows, okay, we want to talk with such a device. Then we need to tell the system just who are we going to talk to, so the recipient. In this case, it can be either the interface or the endpoint. In this case, it's the interface, as we want to establish the initial connection with the serial port. Next thing would be the request, which is basically the what. What are we going to do? What do we want to do? Which kind of command are we going to invoke? And opening the serial port is done via the hex22 value here. Then additionally, we could also send some payload along with the value property. In this case, we don't need to, but we could send a very, very tiny payload. So just some additional hex command, for example. So that could be, if we stick to a robot arm example, that could be, for example, used for telling the arm not to move up only once, but move up like 10 times just by using one command if we send some payload. Always depends on the device. And then again, we need to say, well, to whom again are we talking to? And we're going to talk to interface number 2 in this case. So after I figured that out and after I read stuff and basically built it, it was as easy as porting, well, any Node application using Browserify to the browser. So nothing really scary about that. And then you can have all the wonderful things of Johnny 5 in your browser without any hassle to set up Node.js and so on. Well, next demo. When I was looking up devices I could, well, use for demos, I could use WebUSB with, I thought, okay, what would be an interesting case? And I bought this like very cheap Chinese Android tablet, which has a horrible camera, and I think I'm going to take a picture of all you lovely people. So, smiley faces now. 3, 2, 1. Yep, picture taken. Good. So I thought, like, okay, I mean, this Android tablet probably is a good target for WebUSB as well. Let's see what I can do with it. Well, in fact, yeah, let's just have a look together, because mirroring again, sorry, so on. So let's see. First of all, yeah, it would be quite a shitty experience to show the picture I've took via just using this camera. So let me wire things up to show you the picture. Well, yeah, and then we see already here, oh, it found some hardware. So this is the dialog you usually see. You haven't seen that with my Arduino example because I already connected the Arduino to, well, try things out and see if it really works before I got on stage. But this one I didn't connect before. So this is the dialog, and it's a system and browser dialog you see when you want to attach new devices, when you connect to devices. So let's connect to that tablet. And here you see, if you're familiar with Android development or Android debugging, this is like the screen you get on the tablet when you want to allow USB debugging. So I'll just say, OK, let's do that. And then, yeah, let me see if I can find another way to show you the picture I've taken. So maybe I could just go into the file storage of the tablet and list all the images that are there, all the pictures that I've taken. And it seems like there is one. Well then, let's just see if I can download the picture I've just taken. And it seems like we have one. So let me open that in a new tab. And here we go. There you see how shabby the camera on this tablet is. It's probably like 1.2 megapixels or something. But the thing is, I mean, I just took this picture, connected the tablet, and again, just by using the browser, downloaded the data. Also, I had, as you might have seen, kind of like full access to the file storage and so on. So how did I do that? Let's switch back to the presentation because it's easier to explain with it. Go ahead. So Android USB debugging is a standard. It's specified quite well. So the Android debugger protocol, or Android debug bridge, in short ADB, is very well described. So basically, it's just a matter of turning that protocol description into code. Things with this protocol are kind of like very complex and pretty weird, so it doesn't make really sense to use up the rest of the talk to trying to get into the ADB protocol. If you really want to know how this works internally, there is a package up on GitHub which is called ADB Jazz, which interestingly is maintained by many folks over at Google. And this is basically the thing that I used to retrieve to fetch the picture and to get access to the Android tablet. It's very easy with this ADB library. You just have to say, yeah, I want to connect over ADB, and I want to connect to the host system, and then you have access to the Unix shell of the device. You can upload APKs, download APKs, start programs in the background, have basically access to all of the user data of the user, and that should kind of like ring a bell, because accessing all user data, haven't those WebUSB forks thought about security? Well, of course they did. So a few security measurements. So as you've seen with the native dialog, you can only invoke opening this dialog by using a user gesture. So a click, a touch, etc. Something user initiated must call off this dialog. So this is really one security measurement. You can't just programmatically open up the dialog from just code running in the background of your page. You can't do that. And then, as we've seen with the dialog for the tablet that popped up, the native system dialog from the browser, the user has to explicitly grant permission to use this device on this web page. Also, it is not possible to access cameras, microphones, and storage devices with WebUSB. This has been just not possible. The browser layer that is in there just kind of forbids doing that. And very, well, surprisingly, there is some kind of WebUSB kill switch over at Google. Because with Chrome 54, there was a security vulnerability with a two-factor authentication device, the YubiKey. Maybe you heard about it, that device. So it's just something you put into a USB stick, and it contains a list of your keys for two-factor authentication. You can use it to log on to web pages in a more secure way. And with WebUSB in Chrome 54, it was possible to read out all the keys from the device, which, of course, is a big security issue. So after the Chrome team heard about this, they kind of like flipped the switch and disabled WebUSB in all of the browsers. And it was then reintroduced with Chrome 56, so half a year later, when they finally had fixed the security vulnerability. It hasn't happened since, but it's just, I think it's a very interesting and funny side note that Google is able to turn off an API in all of the browsers. So, next demo, that is the one that unfortunately won't work because of hardware malfunction. Because initially I wanted to recreate the lost art of the Gameboy Printer, like this extremely fancy shit from the 90s, which was a wonderful device because you could just paint something on your Game Boy, or you could print out like high scores and so on. And I'd like to recreate that, and I did recreate that with one of these chaps here, some thermal receipt printer, POS printer. But, well, as said, unfortunately, it only shows me the red status right now, and it doesn't connect to the system somehow. So, the demo I was actually going to show would have been looking like this. So, I created like a tiny canvas where you can paint on, and also as it's a canvas where you could like take pictures and, well, also paint on those pictures in black and white and print that out. But as said, unfortunately, device is broken, so no real live demo of that one. But I'll show you a video later on, because actually there's another demo that involves the printer. Well, going back to, no, not syncing, sorry. So, going back to slides. Connecting the printer is super easy. So after you connected the device, if you just want to print text, you can send text to the incoming endpoint of the device. You just need to use JavaScript's built-in text encoder to encode the string, which just basically turns the string into a typed array. and flush that out via transfer out, and then the printer will print this. If you do want some paintings and artsy stuff, it's a bit more complicated because you really have to, well, learn the steering commands of the printer. This is a bit more challenging. You basically have to take over the steering of the printer pixel by pixel, which isn't that bad because it's very well documented. So all of these printers that I could get my hands on adhere to the POS standard, and that one is freely available on the internet. Also freely available on the internet is a repo I created for a workshop I've done about WebUSB, which, well, is all about those little printers, kind of. There is demos and code which is very thoroughly documented, so easy to follow along, at least I hope so. If you want to know how to steer those printers, how you can work with them, just check out that GitHub repo of mine, and there's basically everything in there you need to steer those printers. So with missing that demo, let's go to the last one I prepared, which is, well, another interesting thing, because I was talking with a friend from the Netherlands like a year ago, and he is creating like cashier and checkout systems for hairdressers. And I thought like, that's actually an interesting thing. Could I recreate this with WebUSB? And so I came up with the idea of creating a public library system. So what do you need when you want to have a book from the library? You need to scan the book so the library knows which books you are renting. You need a way to somehow identify yourself. So I thought, well, it makes sense to use some devices and recreate that with WebUSB. Because the cool thing is, if you have books that have this barcode printed on them, they have the ISBN 13 number of the barcode of the book encoded in the barcode. So this is a uniquely way to identify each and every book. Well, let's just see how that looks in the real world and go to the demo once more. So the last demo for today. That should be this one. Yeah. Let me quickly plug in all my hardware that I need. So this is the part where I envy people who demo web Bluetooth instead of WebUSB, because they don't have to need to plug in and plug out all of their stuff all of the time. Oh. By the way, I love these old devices, and I love them also because of the sounds they make. It's just like, I would have loved to have that as a kid, just because of the sounds. It's so technical. So, yep. Well, first, before I want to rent those books, I have to identify myself as SAD. So I'm using an RFID card reader for this. This one with RFID cards. You're probably familiar with the system. So that one's turned on. Let's see if it works. That was the wrong one. Sorry, I haven't labeled them. Maybe this one? Oh yeah, got it, worked. So next thing we need to do is we need to scan the books we want to rent from the library. And by the way, this is one of my favorite ones, one of my favorite possessions. This is JavaScript, the Definite Guide, released in 2001. It has like a sticker here that says it covers JavaScript 1.5. So basically, this is JavaScript, the obsolete parts. OK, let's go ahead and now I'll probably just see this. Let's try to scan it. Oh yeah, here we go. Found it. Another one I really like, Secrets of the JavaScript Ninja. I think the last book John Resig released. Let's scan that as well. OK, that looked fine. So the cool thing is with having the ISBN numbers being read out from the barcodes is that there are online APIs you can just use from your browser again to look up more details like the pictures of the books or, well, just other details that are stored along somewhere in the internet. just by using that one number. The thing I would like to have shown you then would also print a receipt so that I know when I need to return the books. So it would look a bit like this. So that was a demo when at another conference when the printer was still working. So unfortunately, no live demo for this, but yeah, it sort of works. It's also a bit sad because I basically have 5 of those printers at home, but I haven't had any space to pack some spare parts. So, okay, let's go back to the presentation because we're also nearly done. Start. Good. So, interestingly, you might have noticed that I didn't need it to use like the user select menu to select those devices I just plugged in from the browser, as I did, for example, with the tablet. And the reason for this is that both the RFID card reader and the barcode scanner, both devices belong to a special group of USB devices, so-called HID devices, human interface devices. Many old devices that only needed to transfer numbers or text of some sort, just characters, they kind of behave like keyboards. So essentially, if I plug this device into my USB port, my computer thinks it's a keyboard because it says, hey, I'm a human interface device. Well, vendors do this because to have a higher compatibility with many different systems, because well, keyboard drivers are available everywhere, and they don't need to develop a special driver for this device. HID devices won't be available via the WebUSB API. At the moment, there is a new spec in development that is called the WebHID spec. It isn't out yet, so it hasn't landed in any browser, but, well, I'm waiting for this for about a year to finally have control over those HID devices fully with a proper API that hopefully, maybe, probably will look like this. Reality, though, is if you want to have these devices, you need to do things like this. Never do this in production. Never do this in production systems. I only know one person who does this in production systems, and he knows what he's doing. So this is kind of like the old school way. As those devices transfer just characters, I can use a global on-key press handler to read out the data that they send quite easily. And I know that all of the numbers from this RFID reader, all of the card identifiers are 10 characters long, and they will be, at the end, there will be a return character sent. And as I know that ISBN numbers for books are always 13 characters long, I can somehow distinguish which device is sending data that I plugged in. Really, never do this in production. Sure. So that kind of worked well. Unfortunately, well, without the printer, and I really love this device because I also do wonderful things with, like, I wouldn't say art, but with my little daughter, we try to paint things on the computer, and she's really happy if we connect many of those and have like different streams of like actual paper with her paintings, paintings with her, well, sharply drawn lines. Let's call it paintings with her art being printed out. It's wonderful. If you want to get started with WebUSB, there are some things that help you. So for example, if you go to Chrome and type in your address bar Chrome //device log, you get a list of all of your connected devices to your computer, like all of your Bluetooth devices, all of your USB devices, all of the events those devices send. Interesting that this is in the browser, but it's there. Also, there's something that's called USB internals, which helps you create fake USB devices. If you don't have a device at hand, if you want to test your code somehow, you can create a virtual device just in your browser. Sadly, WebUSB is only available in Chrome nowadays, so Edge probably will follow when they switch the engine. Safari probably never. I've talked to some Firefox people, and they will roll out Web Bluetooth, which is kind of like very close to WebUSB in the ways it's working, later this year, and after that, hopefully also WebUSB. There is a Node package. Well, you were able to talk to USB devices like forever with Node, but this Node package enables you to use the same API in Node as you do in a web browser. So you basically, if you write your USB drivers for your devices, they work in Node and in the browser. So takeaways. WebUSB lets you, web developers, write drivers for devices. It's as easy as that. We can build wonderful things like checkout systems for shops that work on tablets because WebUSB is available in PWAs. WebUSB is available on Chrome on Android tablets as well. So you can plug in USB devices to your tablet and steer them from Chrome. I think it makes it very easy to start to tinker with hardware, like think about schools. So I was a mentor in Cologne Coder Dojo for a couple of years. We had a lot of kids who didn't have a computer, but had like one of those Android tablets. And with WebUSB, we could, well, help them, not by looking up where we can find a computer for them, but using the tablets to actually steer their electronics and devices. So it removes all the hard setup steps for beginners. We can like rebuild, go full retro and rebuild forgotten art like the Gameboy Printer. And whatever we do as developers, I think we should take this wonderful piece of niche technology and somehow do something meaningful with it. And kind of like, I mean, that's all we do as developers, right? We try to improve the lives of the end users. And as we're developers, we can also just like build shitty robots and have lots of fun with this new technology. So thank you very much for listening. I will release the slides, and there's some further readings and further links on this. So yeah, thanks very much.
We have some time for questions. Does anybody have?
Go. By the way, I hope I spelled that correctly. Okay. I mean,
hi. It is spelled correctly. It's just a little bit off the screen. We can't see the beginning of the first letter, but that's not a big point. So the question I have is, you talked earlier about the Android debugging and that you cannot access the storage, but earlier in your presentation you were able to fetch the photo from the device. So what's happening there?
So this is because if you have a USB stick that is storage, that itself tells the computer, hey, I'm a mass storage device. I'm a USB storage device. If I connect this tablet, it doesn't tell the computer that it's a storage device. It says, hey, I'm a tablet. I'm some weird, different, special kind of device. And just because within the tablet software, within Android, there is this protocol for debugging implemented, I can use that because I have shell access, thanks to that protocol, to navigate the file system. I don't have really access to the file storage of this like I would have when I plug in a USB stick. That doesn't work. But as this device doesn't say I'm a storage device, I'm some different kind of device, I can use this device's own protocol, the ADB protocol, which allows me to somehow navigate the file system. I hope that's quite
Okay, I see. So you just use the workaround.
Yeah, because, I mean, this is just not a storage device. Yeah.
So for your Arduino, it seemed to have a particular firmware loaded, so it declared itself as a WebUSB support device. But your printer, let's say, should it work, it probably didn't have such firmware loaded. So does it mean you can almost talk to any USB device through this approach?
I mean, you can talk to almost any USB device using this approach, but the thing with the Arduino is, yes, I needed to apply, in Arduino land, they're called sketches. So if you receive an Arduino from the factory, they're basically blank. There's no software on it. You have to use the Arduino IDE once, and they do have a sketch in the standard library that is just called WebUSB. So you can load this using the Arduino IDE once on the device, and then basically that also implements the Firmata protocol, which is the underlying protocol that also Johnny 5 uses to talk to the Arduino and other devices. And basically it's a sketch that implements this protocol, and it needs to be applied once to the Arduino, but then it's good. Then you have all the possibilities. You can plug in all different sensors and actors and control them or read the sensory data.
Thank you.
So let's thank our speaker for presentation.
I have to thank you.